Welcome. In this session, you're stepping into the shoes of a cloud network architect and planning IP address allocation for a multi-region deployment in Azure. Let's get into the details. Let me walk you through how I planned the IP address space for my Azure network deployment. First, I'm using a private IP address range from the RFC 1918 space. Specifically, I've selected the 10.0.0.0/8 block, which belongs to the Class A network category. This gives me a huge address pool, over 16 million IPs, which is ideal for building large scalable environments without running into conflicts. Now, in this scenario, I'm planning to deploy workloads across two Azure regions, Australia East and Australia Southeast. So what I've done is assign a supernet to each of these regions. You'll see that clearly in the first part of this sheet. Each supernet is tied to a region. From there, I've split each supernet into smaller seeded blocks. These are used to carve out address spaces for different network segments like hub networks and spoke networks. For example, I've got dedicated blocks for VNet Region 1 hub, Spoke 1 and Spoke 2 in Australia East, and a similar setup for Australia Southeast. Some address ranges are intentionally left unused, giving me flexibility for future expansion or redesigns. This sheet helps me visualize and track how IPs are allocated across regions and how the hub and spoke topology is built out. It also ensures there's no overlapping of address ranges between virtual networks. Below that, I've added a reference section that outlines the different RFC 1918 blocks and their properties, just to make it easier when I'm sizing subnets or explaining this to someone else. Let me now take you through the VNet Hubs tab, which builds on the IP supernet planning I showed you earlier. In the supernet tab, I carved out large address spaces, supernets for each region. Now in this sheet, I'm zooming into the hub virtual networks that act as the central connectivity layer within each region. Here, I've created a hub VNet for Australia East and another one for Australia Southeast. You'll notice that both are placed under a common subscription and clearly grouped into separate resource groups. This separation helps me manage regional resources independently and aligns well with a scalable landing zone design. For each regional hub, I've assigned it a specific address space pulled from the supernet I showed you earlier. From that address space, I'm carving out subnets for essential infrastructure services. As you can see on the screen, I've got a dedicated subnet for Azure Bastion, which lets me securely connect to VMs without needing public IPs. Right below that, I've allocated another subnet for the VPN gateway, which I'll use for hybrid connectivity or VNet peering. The remaining subnet spaces are currently marked as unused, giving me flexibility to add more services later, whether that's Azure Firewall, private endpoints, or monitoring infrastructure. By doing this for each region separately, I'm ensuring that both hubs are consistent in structure but isolated in operation, making it easier to scale and secure them independently. This VNet Hubs tab is critical because the hub becomes the backbone of my hub and spoke topology. Everything else, whether it's workloads in spokes or external connectivity, will route through this layer. Now that I've walked you through the supernet planning and shown how I build the hub networks in each region, let's take a look at how I planned the spoke virtual networks for Australia East. In this tab, I've defined two spoke VNets, VNet Region 1 Spoke 1 and VNet Region 1 Spoke 2. Both of these are part of the same subscription and resource group as the hub I showed you earlier, and they're logically placed in the Australia East region. Each spoke is assigned a dedicated address space, and from that, I've carved out subnets for specific purposes. You'll notice I've reserved one subnet in each spoke for general workloads. This is where my Azure VMs will live. Right next to that, I've created a separate subnet specifically for private endpoints. This design allows secure integration with services like Azure Storage or Key Vault without exposing anything to the public internet. Just like with the hub, I've marked some address ranges as unused. That gives me future flexibility if I need to add services like App Gateway, container workloads, or monitoring agents down the line. So the idea here is simple. Each spoke is a purpose-built space for isolated workloads. They'll connect back to the regional hub for shared services, inspection, or internet access via NAT or firewalls, depending on what I configure later. This tab gives me a clear region-specific breakdown of my spoke networks and keeps everything consistent with the broader hub and spoke topology I've been building out. Up next, I'll show you how I've done the same thing for Australia Southeast. Let's keep going. Now that you've seen how I structured the spoke networks for Australia East, let's move on to the Australia Southeast tab, which follows the exact same approach but tailored to the second region. Here, I've defined two spoke VNets, VNet region 2 spoke 1 and VNet region 2 spoke 2. Each is tied to its own address space that was pre-allocated from the supernet I planned earlier. I'm keeping things consistent by using the same subscription and a region-specific resource group, which makes things easier to manage, especially when applying policies or role-based access control. Within each spoke, I've split the address space into subnets just like before. One subnet is allocated for general workloads, where I plan to deploy Azure VMs or other computer resources. Another subnet is reserved for private endpoints, giving me secure access to PaaS services like storage accounts, databases, or Key Vault without traversing the internet. Again, I've kept one subnet as unused. This is intentional. It gives me breathing room to expand later, whether I'm adding app services, private links, or peering connections. The goal here is to mirror the structure I used in Australia East, ensuring both regions follow the same hub and spoke topology and have clean, isolated networking zones for workloads and service integrations. By doing this planning upfront, I make sure that the network remains consistent, scalable, and secure, no matter where I deploy my workloads across regions. So to sum it all up, when you're designing virtual networks across multiple regions, planning matters more than anything else. And using a structured sheet like this gives you, as a network architect, the clarity and control you need over your entire CEDAR allocation strategy. Instead of randomly creating VNets based on assumptions or personal understanding, this kind of worksheet forces you to think holistically. You know exactly which supernet is assigned to which region, how address space is divided across hubs and spokes, and what's in use versus what's reserved for future growth. I always prefer using Excel for this planning phase. Why? Because it's easy to share, especially with non-technical or non-project team members, like security reviewers, application owners, or auditors. You don't have to give them access to an IPAM tool just to see your plan. That said, once your planning is complete, I still recommend pushing this data into an IPAM tool for long-term tracking and enforcement. Use Excel for collaboration and planning, and IPAM for governance and lifecycle tracking. Together, they give you both flexibility and control, which is exactly what you want when managing enterprise-scale networks in the cloud. Bottom line, don't just build networks. Design them with purpose, document them clearly, and communicate them effectively. While Excel is great for planning and sharing IP allocations with your team, you sometimes need a quick and precise way to calculate subnet sizes, understand usable IP ranges, or split a larger block into smaller subnets. And that's where a tool like this visual subnet calculator comes in handy. As shown on the screen, I've used David C's subnet calculator, which is one of my favorite go-to tools when I need to size a network. You simply enter your network address and mask, click update, and the tool shows you the range of addresses per subnet, the number of usable IPs, the subnet and broadcast addresses, a clickable option to divide the subnet further into smaller chunks, and even the mask bits and host capacity of each slice. This tool is especially useful when you are working on your initial supernetting plan, or when you're trying to figure out how many subnets of a certain size you can get out of a larger block. For example, splitting a /16 into multiple /18/19 or /24 subnets is just a click away here. Use this tool alongside your Excel planning sheet. Let the calculator help you do the subnet math, then bring the results back into your worksheet for documentation and sharing. This approach saves time, prevents mistakes, and helps you stay laser focused on network design strategy, not just number crunching.